Last week we started discussing about what is called post-training. Post-training is basically, um, you know, um, uh, how you can train, your LLMs. Okay. Yeah, we talk about in lecture one instead last week. We talk about several other things. For example, we talk about the classical encoder decoder architecture that was used. It does have some dose of this issue, and we talk about saying that attention actually solved the problem. Then we talk about okay, now we have encoder decoder with attention mechanism that actually solved the problem, but still there was missing part in NLP world where when you train a language model, you need to train it from scratch on another task. So that means you train multiple times on different tasks. But the issue is in computer vision, they have been having this transfer learning where you can train on multiple images and then you can actually retrain or train your model on another different image. That's what transfer learning. So we talk about this idea that okay, transfer learning has been with the advent of what we call a new work, which is ULM fit. So ULM fit is basically a work by Jeremy Howard, by Savasya Ruda, developed by this, is pioneering transfer learning method for this. It enabled the effective low data training test classification. It leverages free train domain language model and something like that. So this is basically, you can see this paper has about what is it? 6,000 citations. So yeah, it's a good work, and basically they show that you can do transfer learning in NLP, and that's what really changed the field of, NLP. It really, from that work, we started having seen some work such as BART and GPT, and even the GPT actually started when the UML fit paper was actually released, and that. So that's how we talk, and we talk about, what is transfer learning and what is pre-training. So pre-training is basically you take your transformer architecture or transformer architecture, yeah, get your data, and now you train your model. That's, transfer learning. We all talk about the fine tuning. So a lot of things we discuss, but then we run into saying that for how can you train a language model? We said there are three different approach. The first one is encoder, which is basically one of the example is BART, right? But there are other architectures such as encoder, decoder, and decoders as well. So BART is basically train an only encoder, that is get bidirectional context, and that's how to do it. And you can see here, these are some of the, if this is our transformer, we have encoder architecture. Some of the architectures, the encoder, decoder, so this one, and some of this one. And you can see here, there is what is called BART. BART is another architecture. We have M2M, we have Big BART, we have T5. So what is T5? If you look at this T5 model, LLM language model, um, if you look at what is T5 language model, you can see it's text to text transformer that is called T5. You can see it T5. Text to text transformer. It's a series of language model developed by Google. So you can see the T5 is also developed by Google, right? NLP tasks such as text to text problem. So text to text problems such as, machine translation. So machine translation, some people have used text T5 a lot for, machine translation. You can use it for machine translation, summarization, and question answering. All these are text to text, right? The core concept of that, you can see some of the stuff, classification. So the structure use, the T5 architecture use encoder decoder. So sometimes you can see, oh, this is a language model, but somebody can ask you what architecture that language model is being done. So it's good idea for us to know, okay, if this is ChatGPT, what architecture it has been developed for? Is it only encoder? Is it only decoder? Is it decoder? So T5, you can see the structure encoder, decoder, right? And then there is pre-training. So pre-training is basically, training your language model on a huge amount of data. This is what we already discussed. So T5 was pre-trained on clean corpus, crawl corpus, C4. So what is C4? C4 is basically a very massive data set, on wave. So if we look at C4 data set, C4 data set, yeah. So look at the C4. Okay, this is okay. C4 data set maybe. Yeah, so this is C4 data set from what we call Common Crawl. It's a data set that are being used many cases for training LLM. So this is documentation for it. So yeah, C4 documentation and many other things. So that's basically the C4 is used to train language models such as T5. So that's it. Yeah. So modification compared to original transformer, T5 uses relative position embedding and place normalization. So there are many other things such as these embeddings that's as well. So basically, as you can see here, we have different kind of architecture. So now we have seen T5. What about BART? So when we look at BART, what about BART? Let me ask, BART language model, BART language model. Let's look at AI more. So you can see uh, transformer architecture, pre-training, BART is the first pre-trained on massive data like Wikipedia. So BART is basically from the three you see is the first language model because this is the first one, and yeah, and you can see here they use Max. Do you remember we use Max language model? So BART use Max language model. Remember what we talk about, encoders. So encoder model, they use BART language model, such as this BART. So remember we talk about this, the saying that the classical language model actually, the classical language model actually can be able to see, the front and the back. So we don't want that. And we need something. I mean, we need a language model that can see bi-directional, right? Yeah. So that's what we have. And then you see the BART was trained on what we call Max language model, and that's what we discussed last week. So this is just going back and trying to tell us all these architectures. So we stopped last week about BART, where we said BART was trained on two objectives. Apart from mass language model, BART was also trained on next sentence prediction. All right. Remember, can somebody help us remind us what is next sentence prediction? Last week we talked about BART was trained on next sentence prediction. Can somebody remind us? You can omit yourself and tell us what is next sentence prediction. We said the BART can be trained on next sentence prediction and Max language model, right? Two different kind. So what is next sentence prediction? NSP. Anybody can help? Nobody. So what do you didn't understand the last week session? Next sentence.
So I mixed the last week second course.
Okay. Yeah, and I didn't upload our slide. Oh, last week we did, do we? Anyway, so we talk about saying
I,
that, yes, anybody can help us?
yes, I think so. Like it's more of like predicting a future task used in the VRT, so that it will like help us like the model in particular to really understand the relationship between the different sentences. I
Yeah,
think
so
this is
what
what.
we said, BART architecture was trained on two objectives. Number one, Max language model. So Max language model is that given a sentence like this, I was going to the dashboard in the evening. So you mask or close one word and now give this sentence to because you have the original, but while doing the training, you ask the language model to predict what is max here. That is max language model. So, BART was trained on masked language modeling, right? Not on tags for predicting next word, which we already know what language models does. Language models predict next word in a sequence, right? But um, but Max language model doesn't do that. But in addition to Max language model, BART was trained on what we call next sentence prediction in two tags. So next sentence prediction is this. For example, let me say we have a sentence like this: I enjoy reading a book. I enjoy reading a book. So now, BART was trained on this. Given this sentence, it was given two other sentences. One is, one sentence is basically the next sentence, and the other sentence is basically not the next sentence. So you can see here we have what we call is next, meaning that after this sentence, this is the next sentence. So it's level. This is just like a data set is level. And you can see here the dog run down the street. You can see here actually, it's not next, right? So you can see you'll be given a sentence and you'll be given two sentences and ask which one is next. So this is just like leveling. So this is a data set and this is a level. This is the data, this is a level. And each sentence will begin. So BART was now trained with something like this. You can see we have CLS, we have sentence A, right? We have sentence B, right? So the model must classify whether it's next, which one is next or not next, must classify which of these sentences is next, which is not next. So BART was trained on these two, tasks, which is next sentence prediction and, mask language model. That's what we call, encoder architecture. And these are some of the detail. The BART language model was trained. You can see the data set like Wikipedia, book couples, batch size, training data, optimizer, BART base, and BART large, right? So you can see here we have what we call BART base. So if you look at this BART base, again, face, for example, if you look at this here, we have something. If you look at this, we have BART. You can see we say base. So what we mean by base is that this is, the maybe small one. If we look at the base, it's 12 layers, right? 76, 700 hidden layers and it's 12 here. But BART large, so you can see it's 24 layers. So if you look at this one, this is a base because this is one of the widely look at, community like, follow. But we can also look at BART, not base, large. If you look at the large, you can look at also the large. So you can see this is, the large. So we can have one language model, but we have the base or we have the large. So the base means is the smaller part. It was trained on maybe different, not the data set. The data set may be the same, but the architecture, you reduce the number of layers just to reduce the time it takes for one to train the language model. So that's about training data. This more detail evaluation. We talk about also BART was extended using different kind of architectures. For example, this is span BART. This is Robata. So you can look at another, which is Robata. And, if you look at this one here, we can also ask Robata. So you can see the Robata is basically a language model by Meta, Facebook AI. You can see Robata large. Robata is basically another language model. You can see it's Max language model. Yeah. So look at the example. So you can see here, this is a field mask model Robata large or Masca. You can see it. You can see how the data is presented. Can you see that? And look at the sequence. You can see a male model. Can you see that? I'm passion model. You can see that. I'm professional model. I'm freelance model. I'm young model. And you can see that each one has score. Look at 0.33. You can see 0.1, right? And you can see 0.04. You can see 0.02. You can see 0.21. So obviously maybe This one is the best one, and given the context. So you can see the Max language model tried to predict, stuff. So this is how you can use this model directly with pipeline or Max language model. How here is how to use a model to get the future of a given PyTorch. So for example, if you want to do some stuff, other stuff. So this is just to show us you're already familiar with Hugging Face, how to use this stuff, but just here we are talking about what is really happening inside the hood. We also have so Robata. What is the difference between Robata and BAT? So Robata basically continue training on BAT, like the same thing, but just remove sentence prediction. So you can see here, Robata basically is the same. It just using remove the sentence. It just use one objective function, that is mass language model, and and then it has a very good performance. So we also have another one called SpanBat. You can see here we are using word, we are masking word, but here we are masking span. For example, you can see we mask this word, mask this one, mask this one, mask this one. So the whole span here is masked. So you can see here now we have what we call span bar. So if you go to Hugging Face, you can have span bar, and you can see that. So you can see this is a span bar. Yeah, so this is the spine bird. You can see that, right? So this is basically what the then. So all these one are variant of BAT, but they are built on the same architecture, like that is mass language modeling. There's something, nothing changes. Yeah. So and we discuss also families of BAT, for example. You can see here. Robata, the distal BAT, that is BAT with efficient. For example, if you don't have a very good GPU, you can run what we call distal BAT. So distal BAT is a BAT, but distilled in a way like some of the distal BAT. That is what we call quantization and other stuff. That means this is a small model that you can use. Yeah, distilled version of BAT, smaller, faster, cheaper, and lighter. Can you see that? Because BAT may be very large and something like that. So this is distilled one, and you can use it for many tasks, in your own stuff. You can use distilled BAT because it's small and it also has, faster and also cheaper and lighter. So that's that. That is efficient variant, and we have domain specific. Domain specific means language model that are trained for particular domain. For example, if you are working as maybe geography, or you're working as medical doctor, you can create your own. You can see legal BAT here, legal BAT. So you can see here is a BAT that is trained on legal documents. So this is what we call legal BAT. So that is it. You can create a BAT based on that. For example, we can have somebody can create a Hausa BAT. For example, I believe maybe there is Hausa BAT, right? Some people saw Hausa BAT. You can use Hausa BAT. You can use maybe here this you have something Hausa BAT. Huh? You can see it Hausa BAT. So if you want to create, for example, let's look at this one Hausa BAT. Yeah. Also by display language model, the model was set on Hausa language. You can use this transformer. So yeah, you can see somebody, I don't know, this person, he used something called Hausa Bat. So for example, now we can say, okay, this community Hausa NLP, like, Hausa NLP student, communities can now come together and you can create something called Hausa Bat. Like you can take existing architecture and you continue training it on, you can get a very large corpus and you can continue training it. We'll discuss how you can create a language model from scratch using many different approach. There are existing, for example, script code that you can just run. All you need to have is just access to GPU and other stuff. So this is basically a lot of stuff. We also have multilingual. These are language, for example, this one maybe they are only in English, so they are monolingual. That is what we call in NLP monolingual language model. For example, DistilBAT is monolingual, right? They are monolingual, but we have what we call multilingual. For example, MBAT. So you can see MBAT is multilingual in the sense that if we say MBAT, so MBAT is basically I'm talking about Embar. Yeah. So they put them, I think, here all together. So what I mean here is that the MBAD is multilingual. Want to see the languages? Let me see no, the paper. Okay, so if you look at the language here, you can see here is what language is only English. So when you want to see whether this is multilingual, you can come to the number of languages. For example, if we come here, we have something called multilingual. Let me say XLMR. If you come here and say XLMR, XLMR. Can you see that XLMR? If you come here, you can look at how many languages. You can see you have 94 languages, right? You have 94 languages. That means this is really multilingual, language model. And yeah, so you can be able to quickly use it. And we all know how to use this. You can import your language model and something like that, right? Yeah, so that's what we mean by that. And we have now Afrocentric language model. People from Africa, they can now, create their own. What do you mean by that? For example, they can take BAT base, and now when they take BAT base, they can now get data set for Africa, maybe mainly African language. They can now continue training this one. Instead for them to create from scratch, they can now do transfer learning. They take this BAT existing language model and now continue. So this is what these people do. For example, Afribata, what Afribata does is that it takes BAT language model and continue training on 11 African language. If you look, Afribata, yeah, so this is the Afribata. So it's a pre-trained multilingual language model with 126 million parameters. The model has 10 layers, attention, 7 hidden units. So if you go back here where we talk about the BAT, this is it. You can see them. It's 20 layers. This is 12 head. You can see this is a base, right? BAT base. So if you look at this one here, they are telling you the same thing: 10 layers, 6 hidden attention, and 78 head. So if you look at the this we have 10 layers, 7, 6, 8, and 12 bits, something like that. So they just basically use the same thing and train on this African language. The model has been shown to obtain competitive downstream tasks. So this is basically something they just take, existing language model and to continue training it, and they have that. Yeah, so that's why we're also about Afribata upload this something like this. So um, yeah, so this is briefly. I think some people are saying they were not here yesterday, last week. But yeah, this is it. Any question? Any question? All right. Okay. So let's go on into the second part again. Number 2, lecture 2. Ah, So here we can see pre-training strategy part 2. It's basically, talk continual discussion about that. Now, for example, when you talk about LLMs or when you talk about everything, just people think about, all this stuff. GPT, Cloud, Llama, DeepSeek, Mistral, all these, you know. So all these, LLMs that we see, they are based on decoder only models. So they are only decoders. So the progress on Transformer, Transformer decoder model has been spearheaded to lectures of OpenAI. So these decoder architectures, they were spearheaded by OpenAI because they are the one that started using GPT. And then, now many people are saying, okay, decoder only model, they are much better. These models are exceptionally good at predicting next word, and their progress has been largely, by scaling and a large number of sites. So the more you have the decoder model, the more data size you have and the size of your architecture, the more performance. So, so decoder only model architecture, this what we call causal self-attention. You see, in decoder only models, the models can be able to basically, you know, uh, generate sentences, right? If it can generate sentences, unlike the encoder models, where in encoder, we allow the model to be able to see both left and right. We only ask the model, remember in encoder only model, we only ask the model to predict the mass word. So it can see the both left and right. But in decoder only model, we use what you call causal self-attention, where um, only previous word the model can be able to see. That means this is prediction. In classical sense of prediction, you can predict future based on the previous sentences, right? So here also we can predict the next sentences or next word by looking only at the uh, previous word. So you can see each word can only attend the previous word. It cannot look to the future. The model presents the sequence from left to right. So this is basically what we talk about. Yeah, the Cola only model, they do this and they cannot see the next word. This is what we call causal modeling. Causal, yeah. So the Coda model, you can look at something causal modeling. Encoder only model is called masked language modeling. Decoders where we allow the model while training to be able to see the only previous word is called causal language model. So that's what it is. And you can see here, we said decoders, the what we call triangular attention marks. If you look at this one, you can see here, for example, this is an example. The decoder while doing training, it can only look at this previous one. You can see previous one, but all this one are hidden. The decoder model cannot be able to see the next word. But here you can see in bidirectional LLM, such as BART, where we use bidirectional, where we use mass language model. Bidirectional means it can see all the beginning and the both sides. That is bidirectional. So this is attend to all tokens. Can you see that? But this is what not that is triangular. Must it attend from left context, and you can see it cannot attend all content. Yeah. So that is what we call causal language modeling. We already know that this is how language modeling works. Given this previous word, we predict the next one. The coder only model naturally satisfies this content. They process tokens sequentially. They never look ahead. They generate text one at a time, which is what we know what they do. So that's what we call causal language modeling. So we have seen now the encoder language model. It's called masked language modeling, and while training, we allow the model to see both left and right. But when we want to use um, generate text, that is why uh, encoder only model, so that we have seen. You remember encoder only model, we said, what are they good at? They are good in what we call understanding text. They are not good at maybe generating text generation. So for example, text classification, given a sentence, is this positive or negative? Is this sentiment positive or negative? So understanding text, encoder models are very good at. Yes, encoder models are very excellent at, such as BART. You can see semantic similar question answers. They are very good at that. But they are not good at generating long sentence. For example, now remember, if you go to your ChatGPT, you ask ChatGPT, you can create a very long sentence, right? So the encoder model are not excellent previously on these tasks, but now things are changing. While the decoder only model, they are not good at understanding text because they can see the left and right, right? They can see only the previous text. They cannot only see the future text. So they are good at text generation. So therefore, that is why OpenAI started with decoder only models, because decoder models allow the model to not see the next sentence word, it can only see the previous one, and that will allow it to make a good prediction. If you can make a good prediction without seeing what is ahead, that is a good architecture. So that is that. And here is some of the, architecture, the stack-up transformer, used left, right. They are also called, or you call autoregressive language modeler. Yeah, autoregressive predict next one. This is summary of the decoder only model, such as GPT and Llama. So all the today architecture you see, all the today architecture that you see, they are decoder only model. Yeah. They are coherent long text. They can generate a very good text dialogue. They can chat it. They can generate code, story, and everything. But the limitation does not use future context, so we can on pure understanding. It is not really pure on understanding because it cannot see the, because when you talk about something, for you to understand it, you must know the, neighboring words, right? So it's not good at that, but things are becoming changing now with release of all things since that we have been seeing things, even the decoder only models becomes start to become good at understanding text. These are example of decoder only model. You can see them, GPT, Bloom, Common R, all this one, they are decoder only model. If we look at Bloom architecture, yeah, so look at it. So you can see Bloom. This is a Bloom, 176 billion parameter, 58 languages, and open access. So if we have seen this one, this is a very good, another language model. And for the Bloom, if we look at the paper as well, this is a highly collaborative work. And the Bloom paper, oh no. I think I'm part of this, the work on this Bloom. If you look at my name here, Shamsuddin Hassan Muhammad, this is kind of project that took a year, Bloom, Big Science Workshop, to create this language model. So it is also decoder only model. Okay, looking ahead, the decoder. Okay, that's no, wait. Okay, that's an example we have seen. Mystical, GPT, all these one are decoder only model. So we also have encoder decoder. That is the last one. Remember, we said there are three different ways to create to train do pre-train a language model. Who can remind us the three ways? Yeah, these are them: decoder, encoder, and decoder model. So that's what we are seeing. So this is the last one, encoder decoder, right? Yeah, this the strength, combine the strength of both the wall, combine the strength of encoder, and combine the strength of decoder. So that means the encoder has a strong comprehension understanding, and decoder has strong generation, so generation of text. So this model encoder decoder is actually good in both stacks. Yeah, this is an example of that one. Okay, any question? This is what encoder only models, they are good at understanding. Decoder, they are good for text generation. And encoder sequence transformation. They are good in seq-to-seq transformation. Okay, any question?
So far, I just wanted to ask, are the encoder models relevant right now? Because there's a course we are currently testing at deeplearning.ai. It's about transformers, and they completely shut down encoders. They're only working on decoders. That's what they will cover in the course. So do you have like real-time current use for encoder models?
Yeah, that's a good one. So you can see, as I said, encoder model, for example, such as the very pioneer work, BART, which is this is the very first work that changed everything that we see today. all these, this stuff. This is the very first word, among the first word because um, you know, they create other stuff. So it use only, as I said, encoder, which is basically it's used for sentence, many understanding and other stuff. But as you can see here, now decoder, for example, such as this GPT and everything, they are excellent at even understanding. For example, ChatGPT is even much better than the code encoder model. So as you said, people now moving ahead. In fact, you said that the encoder is spaced out and something like that. So yeah, I think everyone now, when you want to create anything new, nobody will care about creating a language model using encoder model. But I think the purpose is to just bring to the attention about the historical part that we do basically have three ways to create a language model, which is encoder, decoder, and decoder model. So yeah, good. You bring in this one. Even in the books we have currently now, maybe in the future, in the books we have currently now, we have these kind of three categories. Yeah, good one. Thanks, Lukman, for the input. Okay, so that's about pre-training strategies.
Hello?
Yes, go on.
Yeah, I just wanted to know if there's using like a multi-language model. Hello, can you hear me?
You are breaking.
Hello?
You are breaking.
Yeah, can you hear me now? Hello?
Hello? Yeah, we can hear you.
Yeah, I said I just want to know if there was any drawback related to training multilingual models, using multilingual languages models to train some low resource taxes.
So your question is if there is what?
There was any drawback, yeah.
Hello? Can you talk now? I'm engineer because we are
Yeah,
actually. Huh?
can you hear me?
Yes, I can hear you now.
Okay, I said if there was any drawback using multilingual models like T5 to train a low resource taxes, if there is. For instance, it was trained on it can be used to train on different languages. So particularly for Hausa, is there any drawback? For instance, someone used to have
Yeah.
went.
So what is happening is that what I think most people did, because BART is one of the most widely adopted early language models. So people prefer to just take use encoder model that they train on BART architecture. But there are a couple of ones that train on T5 as well. I think what is the name of this work? T5. What is it called? Uh, okay, let me say African languages. Uh, um, this work already for they have this. What is it? What do they call it? Uh, um, let me see this work. Yeah, Afriteva. So they have this, what is called Afriteva. It's basically a T5. If we go to Hugging Face, you can see they have base and they have live. If we go to Hugging Face, you can see that. You can see Afriteva large. So this is basically Afriteva version is multilingual T5 version. You can see the T5 version model pre-trained on Wora with the vocabulary side of this. So this is basically another architecture. So it depends on which one you want to use, but actually the performance, matters. Yeah. So um, that is basically, it just depends on what you want to do. whether you want to use BART, but early, as I said, people were using BART, but people now have now moved on. They are just basically using decoders based model. For example, now if you look at this one, nobody in African, you can see this one African, African. So now you know Quen language model. So African 14 billion is the flagship model of the Afric LLM. So it's basically trained on Quen. You can see this Quen, which is base model. Quen is basically this Chinese company from base, is multilingual. It's a generation language model is decoder only. Generation, we mean it can do generate text and something such as just all the ChatGPT. And you can see that type. What kind of type is causal language model? What do you mean by causal language model? Don't forget we said decoder only. What do we call decoder only model? Decoder models, causal modeling, right? Causal modeling. You remember we said these are called causal modeling. That is modeling, a modeling perspective where you can only see the previous tags. You cannot see this next one. That is called causal language modeling. So that's also the Quen was trained on language model. And you can see training stage, pre-training. So pre-training is when you have a very massive amount of data set and you create a language model. That is called pre-trained. So number of parameters, this number of layers, number of attention and context layers, and this is basically what it is. So when we look at this one here, African by a colleague, Labs, David's lab, they have this. So basically they just continue to, and what they did is that they just take this Quen, the base one, and they continue training it. This is, as you remember, we said that's what we call transfer learning, right? Transfer learning allow you to just continue to learn because this Quen has a lot of experience, like it understands English and many other things, so you can continue training it. And you can see this is what they do. They use number of parameters, context length, training token, and now these are the languages, the Quen support. And what can I do? The Quen can, our training corpus combine multiple high quality African monolingual data. So they combine many data sets, Finware, Wera, this, MATLAB. They also have code, they use a code capability, which is basically a code, mathematic questions. They also create some synthetic data, 334 million tokens, create synthetic data. GPT 4 translate domain specific quantity accurate. So they use GPT 4.1 to do translation of some text. So yeah, and this is African. So you can see now everyone is moving even from the classical language modeling and encoder they are using to do decoder. So yeah, so all these things that you are seeing, they are using decoder models, and that's the future. Okay, any question again? Any question? Okay, let's continue. Okay, so now we have seen that we can create a language models using three architectures, such as encoder. Encoder language model is called causal language model. Don't forget it. Oh no, mass language model. We decoder language model is what we call causal language model, and then we have encoder decoder model, right? Now let's move on to large language models. So now, who can tell us what is the difference between all these, for example, BART, and also, now what we have like ChatGPT? What is the difference between them? Like BART, forget the difference between BART and ChatGPT. What is their difference? Not the architecture. They are all language models, but what is the difference? Is BART also large language model, LLM?
Hello, sir.
Yes.
In my opinion, I think no, because as you explained, BAT is like predicting the mask word, and on the other hand, is classifying them. But in reality, the large language models are generating very large outputs.
Okay. Right. So now, somebody will say, okay, now we are in the era of language, GPT and everything. So now let's revise this language modeling that we know today. Okay, let me see my calendar. Maybe I need to go. Okay, I think I need to go. Maybe we can continue from here, large language models tomorrow. Yeah, I think we can continue from here, large language model, and discuss more. I'm sorry for those that are asking about the recording. Hopefully, inshallah, today I'll upload the recording that we missed even previously. I will upload the recording. Yeah. Okay, good. Any question? Oh yeah, I will also send a slide. All right, I will send a slide. Okay, thank you all, and see you tomorrow. Bye bye. Bye.